Okay, so Dalton's law of partial pressure. It is really very simple, and here's the idea. You have a container with gas. All right, you got these little particles of gas in there. Okay, so you got 15 particles of gas in there. Actually, it should be filled up. We should have filled the whole thing with it. So let's do. Okay, and these are all moving around. We got 25 particles of gas. Okay, if I pump into this container another 25 particles of gas. Right? So now we got to. All right. Another 20. What do you think happens to the pressure inside that container? Not just I don't want to see your increase. By how much? If I doubled the number of particles, what do you think happened to the pressure? The pressure doubles. Okay. So if we double the number of particles, then the pressure doubles. Well, so let's say the pressure was beforehand, the pressure 1 was 1 atmosphere. Okay? And then I added those particles to it, the new pressure is going to be what? 2 atmospheres, right? Okay, it'll be, okay, so, but how much, so what did I do going from pressure 1 to pressure 2? I added an equal number of molecules, right?
Right.
Yeah, okay. So we could say that of these 2 atmospheres, one comes from the green, and one comes from the purple. Right? Okay, this is the idea. That if you have a mixture of gases, okay, if you look at the pressure represented by the individual gases, okay, they represent a portion of the whole pressure. Yeah? So the green gas here, okay, would have, in this case, would have 1 atmosphere. Okay, the purple gas has 1 atmosphere, and so combined, they have a total of 2 atmospheres. So the pressure of the green equals 1 atmosphere, and the pressure of equals 1 atmosphere. Yeah? Okay, so what if I told you that in another container, okay, and mind you, we had 25 particles equaling 1 atmosphere, right? Did you guys catch that? Okay, so what if we do this? Okay, so we did 5 particles of red, 10 particles of purple, and 10 particles of green, right? So we have a 10, 10, and 5, yeah? Well, this adds up to 25, yeah? So the whole thing is going to have what pressure? Right, if we identified that 25 particles is 1 atmosphere, and we have 25 particles here, then this is a total of 1 atmosphere, right? But because we know how many particles there are in there, or we know that it's a mixture of gases, we can actually divide it up and figure out how much of this pressure actually comes from each gas. Well, 5 out of 25 is 1/5, right? So the pressure from the red equals 0.2 atmospheres, because it's 1/5 of the 1 atmosphere. Yeah? And pressure from the purple is 10 out of 25, which would be 0.4. Yeah? Okay. So, the fact that we can do this, that each gas contributes its own pressure within the container to the total pressure of the gas, is Dalton's law of partial pressure. Okay, and so it has a general formula of your total pressure equals P1 plus P2 plus P3 plus, and so on, however many gases you had at, that each of the little pressures of each gas add up to the total pressure of the whole thing. That's it. Now, I can be diabolical and give you different units of pressure. Say this one's, like P1 equals 0.4 atmosphere and P2 equals 26.3 kilopascals and P3 equals 150 millimeters of mercury. Okay, but that's just me being a bud. Okay, because you could then, you would just have to change all of these to one of the other forms of pressure and then add them together and figure out what it is. But that's all. But they still add. Just because they have different units doesn't mean they don't add. You just have to change them to the same units before you add, because you can't add if they don't have the same units, right? Remember that from math? Okay, you can't add meters and yards. Right, okay. Maybe. Okay, but all that's really testing you is if you know how to add them and if you know how to convert them. That's what it's testing you. Okay, so that's partial pressure, and that's it. And it's really fairly straightforward and simple.